Are you able to see? Right? So we'll get started with this chapter today. Okay. So we'll get started with matrices and determinants. In how many schools have they started? Only in your school. So none of you know what this chapter is, right? No idea also. Right? Okay. So how many of you have this thought that math has no application in real life? You feel, right? Math has nothing. Math is useless. All we are studying is useless. Only for 12th standard we are studying. Well, just study, vomit it. Is that a feeling you have? How many of you, be honest, okay. How many of you have that feeling? One girl at least is honest telling. You also feel it. You also feel that. Differentiation part is useless now, feeling. You don't know why you're studying. Sorry? Most of the math is like that only. Math is, see, calculus itself is found, you know who found? Newton. Why he had to do is because he faced problems. See, initially what happened, he saw that apple falling and all those things, that story is there, acceleration, all those story came into picture. Okay. The question is how you calculate it. So when you calculate the acceleration due to gravity, near the surface of Earth it is 9.8 accepted. But you know that Earth is going to revolve based on where the object is there, whether it is at the equator or at the pole, or which coordinate the particular object is located, and the way the Earth is revolving, the value of G changes. So for solving these kind of things, we need calculus. So definitely that was the reason why calculus was invented in the first place. Obviously, right? See, for example, we're able to see this, right? This got fixed today. But are you able to see something around it? Something, there is something that is disturbing me. Are you able to see? What was there previously? Whiteboard was there. That dimension and this dimension was same. The 6/4 is something else. This, so 6/4, if you measure it diagonally, it comes around 86 inches. If you measure the diagonal of this, there's a 65-inch TV. Okay, but what are you able to see? When the board is removed, are you able to see something that is unremoved? Screws are there. Will you be able to remove that screw without a tool? If I ask you to remove it with bare hand, will you be able to do it? So humans are like this. We create problems and we find a solution for it. That's what we do. We ourselves create problems and we'll find a solution for it. So to remove this, what you need, look at the way they are designed. there is something like star that is there. It means I need a particular shape of or a tool for it to go inside, and then it has to turn in the anti-clockwise direction for it to come out. That's how my drilling machines are. The drilling machines are designed. Correct? So like this, math is also a tool only. For whatever problem you find in science, only math is going to help you. Correct? That is one of the reasons why we have calculus especially. So if you look at functions, right, is there any property or anything? It's a big headache if you ask me, right? For me to teach and for you to learn, I understand. I feel so tough looking at your faces. But why do we have it? Why do we have functions in the first place? Why do we need relations? Is there any real-time application of it? Are they going to help us? Do they? So can you give me an example where in real time relations will help you? Stocks is a very big thing. It's used in as simple as forming a cricket team. So you take two Venn diagrams, right? Like you want to, for especially for these IPL things and all, you need to take people from different sets. One person is from Australia, one person is from India, one is from some other team, South Africa, whatever you call it. Right? When you need to pick them, you need to make them fall in a particular set where the captain has to be very careful about certain things. Like can a team win if everybody is a batsman? Can a team win if everybody is a bowler? If everybody is a wicket keeper, can a team win? Obviously, there needs to be some permutation and combination stuff. So one way that you can do is you take a big paper, sit and write on all the permutations, combinations, choose the best one. Or you use a mathematical tool called as relation to solve that problem. So that is why you have this formula. How many kind of relations can be formed? 2 power something. Depending on how many options are given to you. Suppose I give you 21 players, but you have a team of only 11 members. Right? So you need to form a perfect relation in such a way that you have a team that could win. At least you will try to win. That's a different story. Winning or losing is a different story. At least you will try to have it. So math will help you in that way. Right? Especially relations. Why functions is used? Because I told you calculus is used in solve science problems, but at the same time, it is also helpful in different fields where you have packing stuff and everything. Last class I told you. When you want to design a cardboard, right, you want to transfer coke from one place to another. When you look at any business, right, what is the main goal of a business? To optimize money. In the sense, anybody who wants to do a business, what will you do? If you want to do a business, what will you do? I'll give you, let's say, 2,000 rupees and say, you do a small business, make this 3,000 rupees and give me. Is that called as a business? Or I say, I'll give you 2,000 rupees, spend all the 2,000 and come back with empty hands. What is a business according to? What is the objective of any business? To make profits. Right? For that, you of course need to spend, not like you're not going to spend anything and you will take 100% profit and run away. The 30-40% profit, which is a very big number I'm talking about. Right? So this happens. So Coke is a product-based industry. So what do? They have a company where they will design all the tins and everything. So they will have an R&D team who will be specialized in this kind of things. They need to design the tins in such a way that they are cost-effective at the same time profitable also. Because your packing and everything, because what happens? They'll not manufacture everything and they'll keep it in factory, or they want to bring it to consumer. Obviously, transport and logistics are involved in it, right? So when that is there, if I book a truck, will I be trying to send more amount of goods or less amount of goods? More, right? So I need to optimize things. So I need to design in such a way that things are optimized. I'm not talking about minimum or maximum because it is about case study. You're able to understand what I'm trying to say. So that is one such example. Okay, something else I got in mind, but I forgot. Just now I forgot. What else can we think of? Yeah. So that is about calculus. Okay. In a similar way, this chapter, right, it also has some application. Can you guess and tell me what it is? If you ask me, right, without mathematics, I'll say whole world will stop. Whole world will stop. The best tool you have in your Microsoft. You're going to social media. The best tool that you have in Microsoft, what is it? Excel. Do you think businesses can run without Excel sheets? Leave business. Even your data cannot be saved. I'm not sure if you know how your data are saved in school. You will have serial number, your name as per the LOC. Okay, you will have your date of birth, your father's name, your father's occupation, number, everything has to be put in a tabular column. Imagine typing all those things in a Word. I'm not sure if you guys have worked on these softwares. Imagine typing those things in Word and imagine typing it in an Excel. So when you type it in an Excel, what has happened? You can have the data in a row. Right? If I take one person's data, I can have it in a row. And I can have multiple data in a column. So if I take the collection of all these things, what can I call it as? If I have a collection of objects which are placed in rows and columns, what can I call them as? What a matrix is. Okay. And the plural of a matrix is what is? Matrices. I gave you a very simple example. Like this guy was telling me about social media. What is social media? Where is social media? Based on your search, you get suggestions. I think I've seen that. Oh. Okay. So you talk about these platforms, right? OTT, when you got switched on, you saw many OTT platforms like Netflix, then Prime, all those things. You could have seen movies and all, right? Have you ever observed this? How many of you watch movies regularly? To be honest, even I watch a lot. There's nothing wrong. Okay. Be honest. So you guys watch which OTT you prefer? Prime, Netflix, right? Mostly like Netflix, people say it has a good content. Right? When you take that, not everything, I know. But yeah, to some extent, I can say it has a good content. Okay, it asks you, right? Whenever you pause the movie, have you ever seen? It asks you whether you're enjoying it or not. Next time, observe. When you pause the movie, you want to take a break, right? Observe if you ask you for a suggestion, a thumbs up or thumbs down. When you click on thumbs up, right? Next time, have you ever seen suggestions coming up? Based on your previous watch, we are suggesting this thing. So how does the software work? So it doesn't have brain, right? Who's sitting and monitoring that you are watching this movie? Who has time to monitor thousands of users' content or lakhs of users' content? Who's sitting and monitoring? Everything is done by a software. So what the software does is in the back end, if you use the artificial intelligence algorithms to put it in very simple terms. If you're a computer science student, it will use a for loop. This is basically arrays. Right? It will use a for loop, and based on the genre that you have selected or you kept watching for more number of times, it will suggest you more number of movies. So if you see the back end again, you have these matrices. So like this, if you see, matrices has a lot of application. Anyway, don't worry, we are not going to read about all those things. We are only going to be concerned about how to add numbers, how to subtract numbers. It's very simple, okay. But if you look at a bigger picture, right, it has a lot of applications. So my intention of telling this is, math is not waste. We have a lot of applications. Okay. Let me give you one more example of it. You know about these passwords. You enter a Google password, Gmail password, right? So what do you think will happen if the data exactly goes and stores in the central database? You're entering something, password, okay, XYZ, something you're typing for. If it exactly goes and sits in the central database saying that your password is XYZ, what do you think are the dangerous aspects? Especially in the case of banking and all. Banking passwords and all get leaked, what will happen? Your account amount is lost in no time. Right? What do you think if it happens? Obviously, there is a risk, right? Your data will get leaked, which is the most important thing in today's world. Right? So, what will happen to the password that you enter is it will get encrypted. Have you heard this word called encrypted? So, what will happen is your password will be given a number in the form of a matrix, and there will be a dummy matrix that will be created, and these two will get multiplied, and that will give you a new matrix. Are you able to understand what I'm trying to say? So, you entered the password, right? That password will have a matrix form. that will get multiplied with some other dummy matrix that is getting generated, and we create a new matrix. And that data is called as encrypted data. So for the software to process it, you again need to create a decryption process. Okay, that is why you have something called as inverse of a matrix. So basically, there are two operations that we do. One is multiplication of two matrices and finding the inverse of a matrix, like how we found inverse of a function. There is something called as inverse of a matrix also. Why inverse is used in real time is to decrypt your passwords and take out the original data. If the decryption goes wrong, right, again your data will be lost if the software doesn't understand. Every data of yours will get lost. So the whole world needs to be this careful about everything. Okay. So if you want to do something in future with respect to computers, especially cyber industry or something, this chapter is very, very important. Okay, if you're good with it, your thoughts will be better. So if you read this whole story, right, that is what they would have given. So that part I'm leaving it to you. So let's come back to the basics of what a matrix is. Okay, matrix is basically, I will call as a rectangle, simple rectangular box into which you can place numbers or any other data you want. In mathematics, we are going to deal with numbers, but in real time, it can be numbers or letters or whatever it is, or names or whatever you want, you can place it. Is that clear? Okay. So, if you are able to write, see, let us take an example, okay? Since you don't know the chapter, I'll take the example and then proceed. Suppose we have a data in our hand. Okay, the data can be represented in multiple ways. What do I mean by data here? Some information. For example, you take your example, your roll number, your father's name, mother's name, everything is called as a data only. So if I want to store the data, I am comfortable with rows. But I've seen people who want to store the data vertically also. So I'm comfortable with horizontal. Some will store vertically so that you will have boxes like this. So data can be represented in any way, but it can be represented either in the form of a rectangular array, rectangular arrangement, or a square arrangement. So these are the two things you need to be concerned when you're solving problems in this chapter. So you need to see whether you're talking about a rectangular matrix or a square matrix, because based on what kind of matrix you're dealing with, right, there are different operations that you can perform. Okay. So suppose we want to express the information that there is a person named Radha who has 15 books. Okay, she has 15 notebooks. Then what can we do? We may express it as, put a box like this and write it as 15. So what did you do? You put a box and you wrote only 15, where I will say this has one row and one column. So basically rows are something which are placed horizontally. Horizontal are called rows, verticals are called as columns. So one data is represented. So with the understanding that the number inside this rectangular box is the number of notebooks in this context. Correct? So that Radha has. Now, if we have to express that Radha has 15 notebooks and 6 pens, what can I do? I can take the help of linear equation in two variables also, my wish. So what will I say? 15 notebooks and 6 pens. Okay. So what I will do is, I'll give you a problem where I'll ask you to calculate the cost of those 15 notebooks and 6 pens. What will you do? You'll take cost of each notebook as X and the cost of each pen as Y. So you'll start writing it as 15X plus 6Y, which will give you the total spending that Radha has done. Correct? Right. This is one way of representing. So data can be represented in any way. But people have understood that the linear equation in two variables or three variables or whatever you call it has a connection with this arrangement of rows and columns. So they can be interchanged. So about this, you have already learned in your 10th standard. Now we need to extend it and try to understand how to use the data. Is that clear? So here the concept is simple. So we need to express that Radha has 15 notebooks and 6 pens. So we can express it as, put a rectangular box and write it as 15 and 6. So with the understanding that the first number inside that rectangular box, you will understand, if I give you a number like this, that this is related to notebooks and this is related to pens. Are you able to understand? Now, in a similar way, I can write it like this also. I told you, right? Some people are comfortable writing like this. If they give it like this, what will you understand? That this 15 represents notebooks and this 6 represent pens. So going forward, if I have to add the number of notebooks by different number of people, I will start writing the notebooks along horizontal and pens along the second line. Whereas if I write it in this form, in the first form, I'll write the notebooks in the vertical and pens along the second vertical. So this is column representation and this is row representation. So there is nothing new that we have learned. I have a data, I'm just putting the data in a proper universal format so that anybody who's reading my paper can understand. That's it. So yeah. So with the understanding that the first number inside is the number of notebooks while the other number is the number of pens possessed by Radha. Let us now suppose that we wish to express the information of possession of notebooks and pens by Radha and her two friends, Fauzia and someone called Sindhu. Okay. So then what we can do is, we can take the name of the people along one column. So, see, I'm assuming that everybody has worked with Excel. Right. Here or there you would have worked, right? So you would have written something like this: name, item 1. So here I'll call it as item 2. Let's say these are the 3 columns I'm taking. So under the name column, what will I write? I'll write the name of those 3 people. So who are they? Radha, Fauzia, and Simran. Under the item column, so item 1, according to us, what does it represent? It represents notebooks. So I need to tell how many notebooks they correspondingly have. 15, 10, and 13. Similarly, item 2 corresponds to pen. So this is how we represent, and the data will be written like this. In which one? In an Excel sheet. But if the same Excel sheet is written in the form of a matrix as a mathematical student, then you write it like this. You put a rectangular box, and the rectangular box, what will you write? 15, 10, 13, 6 to 5. So it is understood that the first column represents the number of notebooks and the second column represents the number of pens. And along the horizontal, you understood that each data is corresponding to one person. Is it clear? Right? This is a very, very, very basic introduction. Clear, guys? So this is one way. Is there anyone having doubt about rows and columns? So what are rows? Horizontal lines are called as rows and the vertical lines are called as columns. Okay. So here, this is one way of representing. I told you. They have written it like this. The other way of representing the same data would be taking it horizontal. So there is someone who wrote it like this. Then what are they trying to tell? They would have taken notebooks here and pens here. Correct? So it's as simple as it. So in the first arrangement, the entries in the first column represent the number of notebooks. So first entry, in the first entry, the numbers along the first column represent notebooks and the second column represent pens. In the second entry, the first row represents notebooks and the second row represents pens. Okay, I'll not drag beyond this. Now we'll directly get into the mathematical details. Now, based on this, we will see what a matrix is. Okay, please write down the definition. So, I think pronounce it matrix. We call it as matrix. Okay. So, matrix is an ordered rectangular array. So, what do you mean by ordered then? Why do we use the word ordered? Ordered means we need a perfect placement for it. If the placements were swapped, what would have happened? Then things will go wrong. See, for example, I cannot keep the heading as notebook and I enter the data of pens. Then the person who's reading will get confused. Suppose, let's say that's a stationery shop who's trying to maintain the stock. Then what would have happened? Pen cost is different and notebook cost is different, right? He will completely have a mismatch of his accounts. Then he will not be able to tally it. So you should not do it. That is why the word ordered is very important. The matrix is basically an ordered rectangular array. Here the rectangle can be a square also. Because square is a special type of rectangle. So please write it down. Ordered rectangular array of numbers or functions. So when you talk about a matrix, it's not necessary that you should always write a number. You can write a function also. Functions The numbers or functions are generally called as the elements of that matrix, or you call them as entries of the matrix. Call them as elements or entries of the matrix. Okay. So it is it not something similar to set? It's not something similar. So if you ask me, can I represent the same data in the form of a set? Yes, I can do that. See, for example, I give you a set like this. A is equal to set of ordered pairs 15, 6, 10, what was it? 10, 2, 13 and 5. This is also data only. Is it not? It's a data of ordered pairs. What do I mean by that? The first number of the ordered pair that tells me about the number of notebooks, and the second data tells me about the number of pens. I can still do it. But we choose this because there is some convenience in it. Why that convenience? We'll see it slowly. Okay. So what? So like how you represent a set in a with a capital in the capital form, you represent a matrix also in a capital. So the uppercase, it is written A is equal to, you have some data. Here we are not concerned about what the data is. -2, 5, 0, √5, 3, 6. Okay. So how many rows does it have? It has 3 rows and 2 columns. So you generally write it as 3 cross 2. So you write something like this. A person who's reading your paper will understand that you're talking about a matrix which is of order 3 cross 2 or 3 by 2, whatever you call it. Okay. So where the 3, the first number represents the number of, and the second number is the number of columns. That's called as order of matrix. Okay. In the second one, tell me. 3 cross 3. Third one. 2 cross. I have 2 rows and 3 columns. Okay. So in the above example, the horizontal lines of the elements are said to constitute rows of the matrix, and the vertical lines constitute columns of the matrix. Thus, A has 3 rows and 2 columns, and B has 3 rows and 3 columns, and C has 2 rows and 3 columns. So based on this, it leads us to the next concept of order of a matrix. So what is order of a matrix? So if a matrix has m rows and n columns, you write the order of the matrix as m cross n or simply m into n. You write order m cross n, or you read it as m by n matrix. Okay. So referring to the above examples of matrices, we have A is equal to 3 by 2 matrix, B is 3 cross 3, and C is 2 cross 3. You already have written it. Okay. So in general, if you take an m cross n matrix, then you can represent it in this form. So like how you take the name of the set to be in uppercase and the elements to be in lowercase, matrix also follows the same pattern. Name of the matrix is uppercase and the elements present in it will be in the lowercase. So how do you write the lowercase as? So lowercase, and you will put something like this. You will put a subscript like this. 1, 1 means the element A11 corresponds to the first row and the first column. So if I write A12, then what do I mean? A12 belongs to first row, second column. So when you draw a line, they both meet at this point. Okay. Then what will be the next number? First row, third column. When you draw a line, they both meet at which point? A13. Similarly, it keeps on going horizontally. So what will be the last number? So it will be A1n because the second number represents the column. So by looking at the order, tell me n cross n, it has n columns. So the number corresponding to the nth column will be A1n. Am I clear? So what about the second element? Second row. A is an element in the second row and first column. A21. Either A22. A2n varikkum poma. So what will be the last number in the vertical? AM1, AM2, so on till AMN. It keeps going like this. Am I clear with this? Right. So this is how it works. So when you write the elements like this, you put it in a rectangular box, and as a subscript, you will put this n cross n. So that represents the order of that particular matrix. These are all the rules that you need to follow. Is that clear? right? So if I take Aij, right, then what can you say? That element Aij corresponds to ith row and jth column. That is the meaning. So the first exercise will be based on you writing down the elements of that particular matrix. So there will be a condition that will be given and you need to write. But before that, there is a note given. In this chapter, we shall follow the notation capital A is equal to. So the general way of writing a matrix of order m by n is A is equal to, I'll take only one general element Aij, where the order of the matrix is m cross n, to indicate that A is of matrix, A is a matrix of order m cross n. Okay, Aij means you understood, no? You need to write it as A11, A12, A13, so on till A1n. Means the expanded form looks like this. The expanded form looks like this, but if there is a way where you can write it in the simplest form, you put a rectangular matrix, you write only one general element Aij and put the order at the bottom of it, m cross n. Here. So we shall consider only those matrices whose elements are real numbers or functions. So in math, when we are going to solve in this chapter, we are going to be concerned only with those matrices whose elements are either real numbers or they are some functions. We will not consider complex numbers. So those are dealt in the competitive exam. Okay. So we can also represent any point xy. This is what I told you about the ordered pair. Ordered pair, that 15,6. That thing I told. No, it is an ordered pair in a plane by a matrix as x, y. Or you can write it horizontally also. For example, point P01, if the same point you want to, because I told you one thing, remember A1 to Abdina, what is it? First row, second column. Y-axis and x-axis are meeting at this point. So that point corresponds to that particular ordered pair. So 0, 1, how will you write it? You can write 0 and 1 along column, or you can write 0 and 1 along the row also. It is up to you. There is no hard and fast rule. Okay. You can follow any convenient method. Okay. So based on this, I want you all to read this statement. Don't look at the bottom. Try to write things on your own. What are they saying? Observe that in this way, we can express the vertices of a closed rectilinear figure in the form of a matrix. So if I have a rectangle, those rectangles are vertices. Let's say those vertices are represented in the form of coordinates. What are the coordinates? 1, 0, 3, 2, 1, 3, and minus 1, 2. Can you represent those coordinates, that is the ordered pairs, in the form of a matrix? Can you do that? So look at the first element. Start writing them along either row or a column. So how many ways can you represent? How many matrices can you write? 2. One is taking along horizontal separately and vertical separately. Write it down. So how will you write? So I can call one of the matrices as capital X. So what is this capital X, guys? I'll put a rectangular array, a rectangular box like this. So I'll take the first elements 1, 3, 1 and minus 1, or 0, 2, 3 and 2. That is one way of writing. Or I will take another matrix Y and write it as 1, 3, 1 minus 1, 0, 2, 3, 2. Does it make sense? Right? So I have done my job of creating the basics. No problems are very simple. Can you start solving them? So let's look at example 1. So the first exercise is mostly about data representation. Okay. So consider the following information regarding the number of men and women workers in the factories 1, 2, and 3. So the factories are taken along the vertical. Men workers in the corresponding factories are also taken along vertical, and women in the vertical. Represent them in the form of, so represent the above information in the form of 3 cross 2 matrix. Means they want 3 rows and 2 columns. So how will you write it? 30, 25, 27, 25, 31, 26. Is it not a 3 cross 2 matrix? Is that right? All of them. That's it. Okay. So please start doing them. These are all very, very, very basic things. First, start with examples. So if there is a matrix which has eight elements, what are the possible orders it can have? So it can have one row and eight columns, or so you do the reverse row. One row, eight columns, or eight row, one column. So what are the next multiples? So basically, if you look at eight, you take the factors. So what are the factors of eight? So 1, 8, 8, 1, 2, 4, 4, 2. That's correct. Suppose I change the question. If a matrix has 9 elements, what are the possible orders it can have? 1, 9, 9, 1. That's B. You can either write it as a 1 cross 9 matrix or a 9 cross 1 matrix, or 3 cross 1. So 3 cross 3, the number of rows and the number of columns are the same. Those kind of matrices are called as square matrices. About them we have in our syllabus, we'll discuss. Okay. They are two separate because one is called as the base matrix and the second is called transpose. So if a basic 188 one 18 if you call it as the base matrix, 81 is called as the transpose. Transpose now interchanging the rows and columns. About that we'll see. Okay, we have that. So can you guys try the third one? So they are expecting you to construct a 3 cross 2 matrix whose elements are given by Aij is equal to given as Aij is equal to half into modulus of I minus Bj. So there is a modulus B very careful. These all the elements are supposed to be possible. So don't look at the solution. Try it. Okay. So what is the order? 3 cross 2. What will be the elements? 1, 1, 1, 2, 2, 1, 2, 2, 3, 1, 3, 2. Better. So A 1, 1 and a 1. In the place of I put a 1, in the place of J also put a 1. So when you put that 1, what will happen? A 1, 1 will be how much? Half into 1 minus 3. So 1. Modulus of how will minus come? Okay. 1. Is it you? So they should finish the line. Keep going. Keep going. Don't wait for me. If you have any doubt, ask. Guys, those who are online are able to do?
Yes, sir.
Yes, sir.
Ij is any numbers, right?
No, Ij should be, see, look at the order of the matrix, 3 cross 2. So the elements will be 1, 1, A1, 2, A21, A22, A31, A32. Okay. So I and J can take 1, 1, 1, 2, 2, 1, 2, 2, 3, 1, 3, 2. So individually substitute those numbers at that point and you will get 6 elements. Write those 6 elements in the places of A11, A12 and so on.
Yes.
Clear? Okay. So if you're done with it, shall we proceed with the next one? Now we'll see the types of matrices. First is column. See, if you look at the name, half of the matrices names you'll understand. First is called as column matrix. Means it has only columns. It has only one column, but multiple rows. So one column but multiple rows is what is called as a column matrix. Okay. For example, A is equal to 0 root 3 minus 1 half. If you see how many columns are there? 1, and how many rows are there? 4. So what is the order of the matrix? 4 cross 1, right? Or you read it as 4 by 1. Okay, both are right. So basically, if you want to write the general matrix form of a column matrix, you write A is equal to Aij with the order of m cross 1, except. Next is a row matrix. You guys guess it. What is it? Which has one row but multiple columns, right? So example is given, minus half root 5 2 3. It will be of the order of 1 cross 4, right? Then what is a square matrix? So matrix which has equal number of rows and columns is what is called as a square matrix. When you take an m cross n matrix, if you can call it as a square matrix if m is equal to n. Correct? So how do you generally write a square matrix? You will not write it as m cross n. You generally write it as square matrix of order n. That is how you say. So square matrix of order n, Abdina, it is understood. It has equal number of rows and columns. So this is a square matrix. Okay. So general representation is Aij m cross n, which is a square matrix of order n. Okay. Then there is a note given. If Aij is a square matrix of order n, if Aij is a square matrix of order n, then the elements A11, A12, ANN means these elements A11, A22, A33. So these elements are called as, what do they represent? Diagonal elements, or constitute the diagonal elements. But see, just because square has two diagonals, don't get confused. Here, with respect to matrix, diagonal elements are the ones where the row and the column are same. A11, A21, A22 and A33. Whereas if I take the opposite side, what will happen? This will be A13, this will be A22, and this will be A31. So that is not called as a diagonal elements. Okay. Diagonal in this case only represents from left to right. Seriya? So be careful with that. So next is a diagonal matrix. Okay. So diagonal matrix, the most important thing is, the first point to be noted is it should be a square matrix. Please underline it. So can you call a rectangular matrix as a diagonal matrix? No. So a square matrix Bij of the order m cross m is also said to be a diagonal matrix if all of its non-diagonal elements are 0. So what are the diagonal elements generally? A11, A22 and A33. Except those elements, if all other elements surrounding them are 0, then you call that kind of a square matrix as a diagonal matrix. Next is, so example is given. For example, A is equal to 4. Yes, you can call it as a diagonal matrix because you don't have other elements. Look at B, minus 1, 0, 0, 2. So except the diagonal elements, every other element is a 0. What about this one? Except the diagonal element, every other element is a 0. So all these are called as diagonal matrices. Does it make sense? So next is a scalar matrix. So scalar matrix takes the connection from a diagonal matrix. So diagonal matrix itself is a square matrix. So what can you say about a scalar matrix? It should also be a square matrix. So a diagonal matrix is said to be a scalar matrix if its diagonal elements are equal. Okay, the diagonal elements of a diagonal matrix are equal, then you can call it as a scalar matrix. Puriyada? See, for example, 3. Minus 1, 0, 0, minus 1. Then what about this? Root 3, 0, 0, 0, root 3, 0, 0, 0, root 3. Then The last important one we are going to see for today is identity matrix. So what is an identity matrix? All the diagonal elements. So identity matrix is also a square matrix. In a square matrix in which all the diagonal elements are 1. So I can call a special type of a scalar matrix where all the elements in the diagonal are 1. So this diagonal matrix is very, very important because I told you about cryptography concept. There we find inverse law. So when you want to find that inverse, you need this identity matrix. So, yeah. So this is all about, okay, there is one more, right? I'll complete this one. So zero matrix means obviously what? Every element is a zero. So, yeah. So these are the outline. Then in the next class, we'll see about the equality of matrices, then how to perform the operations between them. As I told you, chapter is very simple. So, yeah. Easy only, no? Yes. So I'll see you all.
Sir, not able to hear you, sir.
Guys, those who are online, I hope you are clear, right?
Yes, sir.
We'll wind up, okay?
Okay, sir. Thank you.
Thank you, sir.
Hey, in the chair, rather. In the chair, rather, I need to put some oil. Sandhya's chair, okay. I'll position for it. Okay. I need to put some oil for it. Okay.
Thank you, sir.